Hello guys, welcome back to our series of training sessions. My name is Michael Wilson, Chief Trainer for the Ghana Robotics Academy Foundation and a Chief Technologist at the Council for Scientific and Industrial Research Ghana. In our previous session, I introduced you to how we can put together a simple robot and why we put the various parts together. In this session, we'll be looking at the principles behind instructing this robot to perform specific tasks. I'll focus on how we apply our maths, science, and logic in this session. To have a clearer picture, let us look at human beings. We are born with a brain, hands, eyes. However, it is difficult for us to coordinate these actions to perform any reasonable task until we are taught. So in a way, we want to teach our robots. To be able to teach our robots, I want to introduce you to the principle of classical control systems. It is quite simple. So, classical control systems allows us to automate any system. When I talk about a system, I mean any setup that we will want to have control over, or any existing setup. So if I take this robot as my setup or my system, the question is, how do I control this system or automate the actions of this system? I want to automate the actions of this robot. It is simple. Let's take a simple chocolate factory as our use case. So in a chocolate factory, I have this bowl of chocolate. This bowl of chocolate is on a burner with heat being applied here. The requirement is that chocolate is best enjoyed at 15 degrees Celsius. Let's take that as an example. So this chocolate is to be kept at 15 degrees Celsius. Or let me raise it. Let's say we are doing hot drinks. So we want this chocolate at, let's say, not very hot, just kind of lukewarm, so 45 degrees Celsius. Now, how do we automate this setup or this system to ensure that chocolate is always kept at 45 degrees Celsius? To automate this, we'll visit our robotics principles from session 1. We first of all have to identify what sensors will help us automate the system. A temperature sensor is likely going to help because we want to keep the chocolate at a constant temperature. So I get a temperature sensor. But what is the temperature sensor supposed to do? It is supposed to measure the temperature of the chocolate to check whether we are keeping the chocolate at the required temperature or not. So I dip a temperature sensor into this chocolate with a cable connected to the temperature sensor. So whatever temperature is measured, it is transmitted over the cable just like the nervous system from our previous session. And where does it connect to? Your guess is as good as mine. To a computer. The computer is supposed to process the temperature coming in and check whether the temperature is above or below the required temperature. Now, this temperature or this computer, after making the comparison, is going to come out with a yes or no answer. Yes, the temperature is above the required temperature, or the temperature is below the required temperature. There could also be the output of the temperature is equal to the required temperature. So it depends on what computation you do within the computing unit. That is the task at hand. The programmer's job is to create that logic into the computer such that the input T, representing temperature, after going through that computation, will result in a yes or no answer. When a system is designed in this state, we can say that this system is a finite state machine. So finite state machines are one form of classical control principles. You design a finite state machine which is supposed to put this system in one of two states. So let us ask ourselves, what are the states of this machine? We have a heating element here, which can either be increasing the heat being applied or decreasing the heat being applied. Based on the output of this computation, we could then say if the answer is a yes, so in which case I'm going to come up with a simple comparison. We've all studied logical operations. So let's look at comparisons. The symbol greater than. So if the formula put into this computing unit is the formula T greater than 45, what that means is that whatever temperature comes from the temperature sensor, T, is compared to 45. If T is greater than 45, then the result is going to be a yes. If T is not greater than 45, that means if T is less than 45 or if T is equal to 45, the result is a no. So what we are going to say is that if T is greater than 45, then the temperature should be coming down. Else, if T is less than or equal to 45, then the temperature should be going up. So as the temperature drops below 45, the burner gets into the heating state. And if the temperature goes above 45, the burner goes into the cooling state. So this is a heater or a cooler, which means our two states here is the heating state and the cooling state. So out of this, we want to design a system which we call a finite state machine. So what we have designed here is a finite state machine where a temperature sensor takes temperature readings from chocolate, a bowl of chocolate, feeds that temperature into a computer. The computer performs this processing logic of comparing if T, that's the temperature, is greater than 45 or not. The result, which is a yes or no, is used to decide on one of the two states, the heating state or the cooling state. So it is either we are heating the chocolate or we are cooling the chocolate. So this is the principle of a finite state machine. I hope you understand. In the next lesson is going to be a programming session. I'm going to demonstrate how to program a simple finite state machine for this mini robot I have here. I will connect a touch sensor to this robot, and then we program a simple finite state machine such that the robot is either in the moving forward state or the moving backward state, depending on whether the touch sensor is pressed or not. That would be our first program. If you have any comments or any questions, leave them as a comment and we will do well to address all your questions. Thank you.